Hi, I'm Jaden, and you're watching the YouTube channel known as Hyena Waffles. Today, we're going to talk about how big can numbers get. Well, your initial reaction is infinity, but really, is infinity a number? I mean, infinity is so vague that we can't accurately calculate it. We don't even know if infinity divided by infinity is infinity or 1. So, to find out if infinity is a number, we're going to have to look at the definition of a number. I've got the definition of a number right here, and it says, an arithmetical value expressed by a word, symbol, or figure, representing a particular quantity, and used in counting and making calculations for showing order in a series or for identification. Now, everything looks fine, doesn't it? I mean, infinity pretty much matches up with this definition. Except for one point. Right here when it says, used in counting and making calculations. Well, like I said earlier, you can't really make calculations with infinity. Now, to find out how big the biggest number is, we're going to have to start small, with 1,000. 1,000 is equal to 10 times 10 times 10, or 10 to the third power, since it's being multiplied by itself 3 times. 1,000 is also equal to 1,000, and a million is 1,000 thousands. It's also equal to 100 to the third power. A billion is 1,000 millions, and a trillion is 1,000,000 millions, or 1,000 billions. And a trillion times 1,000 is a pentillion. Really, you can keep going up and up and up and up. But let's skip that and go all the way up to 1 googol. What's a googol? Well, a googol is equal to 10 to the 100th power, which means that it's 10 multiplied by itself 100 times. In common terms, a googol is equal to 10 duotrillion. That's pretty big. If you were to actually print out 1 googol, it would look like this. But there's actually a number that's bigger. What's 10 to the googol power? That is what we call a googolplex. But there are numbers larger than a googolplex. Now, you're going to have to understand, people can't write this down as a regular number in regular format because you're not going to have enough space. Even if you have all the space in the universe, you're not going to have enough space. Even if you try to do it with exponents, you wouldn't have enough space. So, mathematicians invented what is called the power tower. And in the power tower, the second exponent is the exponent of the first exponent. And if there's a fourth exponent, it's going to be the exponent of the third exponent, and so on and so forth. Now, to explain this better to you, let me draw an example. 100 to the second power to the second power. Now, 100 to the second power is 10,000. Now, since we have that second exponent, we're going to take that and multiply that by itself. So, 10,000 times 10,000 is 100 million. So, 100 to the second power is equal to 100 million. But even still, to get to the number that we want to get to, power towers are inadequate. So, mathematicians use something called up arrow notation. This video here, I think, describes it very well.
You start with a small number and a 3. 3 is a small number. What you can do is you can start adding 3 to itself. So you could do 3 plus 3 plus 3, and you keep going. In fact, what I've done here is I've multiplied 3 by 3, right? So you could just do 3 times 3. That works just as well. And if you want, you could do lots of these. You could do 3 times 3 times 3, and you can multiply it lots of times. And that that's 3 cubed. Okay, and that's 27. So we're happy with that. I could write this another way. The way I would write this down in arrow notation would be I'd write 3 arrow 3. And that just means the same thing. 3 multiplied by itself 3 times. Hopefully you're still with me at this stage. Now I say, what's 3 double arrow 3? You do 3 to the power of 3 to the power of 3. We would write that as, that is 3 to the power of 3. So this means 3 arrow 3 arrow 3. Now what does it, well 3 arrow 3, well we've already seen that that's 27. So 3 arrow 27. Okay. And 3 arrow 27, well that's 3 to the power of 27. And if you actually work that out, it comes out to be around about 7.6 trillion. Now at this point you can go wild, right? How many arrows do you want? So the next one, let's say we did 3 to the power of, arrow, or whatever you want to call this, 3. Well, that is equivalent to 3 to the double to the double to the 3 to the double to the double. That's 3 to the power of 3 to the power of 3 to the power of 3, and that stack is 7.6 trillion 3's high. And you start from the top and work your way down, and you get an almighty number. You get a number that is absolutely off the chart. You couldn't write these numbers down.
Now that we understand arrow up notation, we can now look at the largest finite number that humans have calculated. Now, I am using Wikipedia to explain this. Using Knuth's arrow up notation, Graham's number G, as defined in Gardner's Scientific American article, is this equation, where the numbers of arrows in each layer, starting at the top layer, is specified by the value of the next layer below it, that is, this equation. And where a superscript on an up arrow indicates how many arrows there are. In other words, G is calculated in 64 steps. The first step is to calculate G1 with 4 up arrows, which mean blah 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 blah. So basically, you get that even the largest finite number that humans have calculated is so large that the system that we came up with to write it is so complex that it's really confusing. Like, that's how big of a number, that's how big numbers can get. And that really shows you the power of numbers.